Seminar 1 is work and energy. The human body takes on energy through food, and the energy content in food is measured in joules. A kilojoule is 1000 joules. We exert energy or expend energy by performing work, mechanical work. Now, work is the amount of energy that's transferred by a force, and the unit for this is also the joule. So work in joules is equal to force in newtons times distance in meters. So for example, if we had an object that we wanted to move 1 meter and it took 1 newton of force to move it, we would have exerted 1 joule in energy in doing so. Task 1 on your worksheet is to record the energy content of 2 food items, which I'll present in a minute. Using those energy contents, calculate, using the equations given in your worksheet, the amount of mechanical work during stair climbing required to exert this much energy, i.e. the number of steps, and then approximate a time that it would take to expend this amount of energy. Now you're going to have to decide on an appropriate rate of stepping in order to estimate a time here in steps per minute. Now remember, in this case in stepping, the work is in the vertical direction, so it's a lifting force. So we're lifting against body weight over a distance of 1 meter or a distance in meters. So here are the foods that you can use to calculate the work in task 1. The highest amount of kilojoules out of these food items is the blueberry muffin, followed by the toast with peanut butter, that's without butter. Pizza 1 slice is next, followed by the cola, the normal beer, and then the low carb beer closely behind. Most of the kilojoules in beer come from the alcohol content. And then the apple is last. So using these figures, go about calculating the amount of work in step 1. Now the human body can't convert chemical energy, i.e. food, into mechanical energy with 100% efficiency. In fact, the body is at most only 20 to 30% efficient in doing this. The rest is lost as heat. So to calculate how much energy is burnt or expended during activity, we don't measure external work, but oxygen consumption. We know that 1 litre of oxygen is consumed with 21 kilojoules of energy. So, let's say we measured a 70 kilogram person in the lab stair climbing as consuming 1.5 litres of oxygen per minute. Task 2, calculate how many minutes of step climbing is required to expend the amount of energy contained in each food in task 1. Task 3 relates to power output. So in exercise science, we're concerned with the rate of energy expenditure, or the rate of work, not just how much work is done. And the more work that's done in a short period of time, the more power there is. So task 3 is to calculate the power output and settings required for a Monarch cycle ergometer. The solutions you should have got for task 2 is 47.5 minutes of stair climbing for the muffin, 32.8 minutes of stair climbing for the toast, 30.7 minutes for the pizza, the cola is 22 minutes, the beer is 17.8, closely followed by the low carb beer is 13.2 minutes, and the apple is only 9.6 minutes of stair climbing required. The solutions for each of the questions in task 3 are, for 1, it's 120 watts. Question 2, the force required was 30 newtons. And in question 3, it's either 40 newtons at 50 revs per minute or 25 newtons at 80 revs per minute will give you 200 watts. Or, if you're already conducting an exercise test at 60 or 70 revs per minute, 35 or 30 newtons of force will give you 210 watts, which is close to 200 watts. You can't pretend you're working at 200 watts, but you'll be close, and it may be preferable to get close to it rather than to have the subject change cycling cadence midway through the test.